So what I'm going to talk today is about the climate crisis, Indian monsoon, and sustainable development. I have been concerned about this problem of being very passionate about the environment and how we are degrading over the years. I have been very concerned about going forward, can we continue the kind of development that we have been doing? And this is, today, my talk is more on that than on the Indian monsoon. I will not talk too much about the technicality of the Indian monsoon, how it changes. I will give a small introduction to that. But I will talk about generally about the crisis and what we need to do about development in the sort of, and where do we stand, and can we continue to do what we are doing today? And that is my, basically, I want to start that dialogue and sort of let people come up with strong messages to the government that we can't do that and change this. So that will be my objective. And so I'll start with this. I like to start with this, picture, because this is what, this is a picture of the last year's floods in various parts of the country. And this is just a sample. If you remember, 2022, we had floods all over the place. In Maharashtra, Rajasthan, Gujarat, Tamil Nadu, even summer months, Tamil Nadu, we had floods, which is unheard of, because in summer, normally, Tamil Nadu, you will not get much rain. But it started getting more rain, floods, and so on. And of course, in Assam, we had a big flood in the early parts of the... So these... there are two types of floods, as you know. These are these flash floods in urban floods and flash floods. These are small-scale floods. And there are also large-scale floods which affects a very large area, like a big river basin, which happened, for example, in Gujarat and Assam, and in Pakistan last year was a huge flood which has really crippled their economy in 1 year. So these things are going to increase. And over the years, it is going to increase so much that it will probably cripple our economy. And that is something that we need to be concerned about. I don't think people are concerned because this we predicted about 15 years ago. And then my colleague is here. We published this paper about 15 years ago. And so that these very heavy rainfall events are going to increase and has doubled in 50 years. And they are going to double further. And because as the temperature is increasing much faster now, they are going to also increase faster in the coming decades. And this, what does this doubling of these numbers means? For example, these events over the central India, this 15 centimeter per day rainfall. This is about 100 kilometer by 100 kilometer place. If there is 15 centimeter rainfall, that's pretty big. And when this kind of thing happens, these are called our mesoscale systems. These systems produce huge rainfall, and it has the potential of producing flash floods. Now, these systems, suppose there used to be 10, and it has become 20 now over the central India. So that much increase in the disaster potential has increased. And now it is increasing to about 25 or more in the recent years. So this is a serious problem. And I think we did not realize, and we have not taken any adaptive or preventive measures for these so far. So that is one of my concerns. And also it associated with this, of course, the slow and small and small events, rainfall events, which actually produces the recharge of the groundwater are decreasing. Those So these are the small events, they are decreasing. So these two things actually is going to produce a very serious effect on our water availability and water resources. So let me start with so with that background, let me start with the climate crisis. Now, how did the climate crisis start? Actually, if you think about the earth and the environment, the climate and the environment is very much intimately related. The climate affects the environment feeds back to the climate. So these things, over the evolution of the whole history of evolution of the earth, last 4.6 billion years, climate has changed, environments have changed, and finally, over the last 3 million years, we have come to a climate which is now like what we call Goldilocks climate, where it is not too hot, not too cold, life can sustain, and humans can live happily. But this has happened, but due to the intelligent human being history is only about 10,000 to 12,000 years long. But during this period, we have changed the environment at such a, or degraded the environment at such a rapid rate that today we have landed up in a crisis which is now threatening what is called the initiation of the sixth mass extinction. So this is basically due to the growth of human activity and human population, which is what I am going to show you, and how the developments have accelerated this degradation. So I'm going to talk about basically what is the climate crisis. Basically, what is the physics of the climate is essentially is an interaction between the earth and the environment, where atmosphere, ocean, cryosphere, biosphere, and hydrosphere, they all interact. And how the humans have essentially created this crisis. Then I'll talk a little bit about what is the current climate change and how it has affected the monsoon very quickly. Then I'll talk about some of these other problems, like how industrial revolution and economic growth has contributed to this, and how our current model of development is not sustainable, and what we might need. So, what is the climate? Climate is essentially the interaction between is essentially the heat balance. Climate is, if you think about very simply, climate is the temperature is one of the major is the parameter that we associate with climate, and of course rainfall is another one that will go along with it. So then the temperature is a result of the heat balance of how much it is receiving and how much it is losing, and that heat balance is affected by all these components. How much water is there, how much land is there, how much vegetation is there, and how much they are changing, and how much radiation it is coming from sun. And this essentially because of that, because they can affect the heat balance, and they will affect the climate. And so we need to include all these components in calculating the heat balance of the earth, and therefore the climate. So in a very simple way, this heat balance can be calculated in a very simple manner. Suppose if you think in Earth as a sphere, you think about how much solar radiation is coming, and the solar radiation essentially goes through the atmosphere almost unabsorbed, because atmosphere cannot absorb the short wave radiation that is coming from sun. Most of it goes through, then the earth gets heated up, then it radiates like a black body, and then this black body radiation is in the longer wavelength, like heat energy. That heat energy then gets absorbed in the atmosphere because of certain constituents like carbon dioxide and water vapor, and then a part of it gets lost to the space. So if I balance this, how much is received, and how much is lost to the space, and then I get a temperature, and that is dependent on three factors. One, how much energy is coming from the sun, what is the rate of energy coming from the sun. Another is the reflectivity, how much is reflected back. That is called albedo. And the third factor is how much is absorbed in the atmosphere due to this constituents of the atmosphere. This is called atmospheric transmissivity. So if we know these three factors essentially balance, sort of control our climate, and therefore the variation on any of these factors will essentially change the climate. So, and they can vary for various different. So one of the things that will vary is how much solar radiation is coming from, and that solar radiation change is dependent on the position of the earth and its motion around the sun, and, and this axis in the ecliptic plane, and that is determine how much radiation can come and be received at different latitudes. And that can have variations at thousands of years in time scales. And those are called Milankovitch cycles, and those can actually change the climate. And one of those variations essentially lead to what we know as glacial, interglacial variations. So I'll refer to that a little later. So now let us look at some of the, to understand the present day climate, we need to understand how the climate has changed in the past a little bit. So if you see over the last half a billion years, 500 million years, the temperature of the earth seems to be cooling. And there were periods where there was so this is the kind of level of Earth's temperature where the polar cap may be completely vanished. And that happened, and there was certain around 350 million years period. There was a huge period where, or a long period where the Earth was completely covered by ice. And then things changed, became warm. Then in fact, this period there are probably even in the equatorial region there are probably even the lakes dried up completely. There was no. So, but then it cooled down further, and this is recent is here, very short period. Sorry, let me go back. So. And this is the recent period is where we are actually, the climate is comfortable, as I mentioned, is habitable. And here we had, now let me go to the next figure where I changed this scale slightly, and so the scale is now in a variable scale. So this is in millions of years, thousands of years, or sort of tens of millions, hundreds of millions, and things like that. And here it is tens of thousands of years. So I expanded the scale in the recent years so that you can see what is happening. In the recent years, about 3 million from about 3 million years ago, Earth started making sort of a stable climate evolved, over which we had a lot of oscillations in these time scales of about thousands of years, 20,000, 40,000, 100,000 years time scales. And these are what we call the glacial, interglacial cycles. In the recent 1 million years, they are dominated by about 100,000 year cycle. This is where ice age is interspersed with a warm period. Today, we are in a warm period. It is called the interglacial period. And this period, now what is happening is that in this period is in the recent years, it has increased so much, it has gone almost above this level, okay? And that is our major concern. Now, the problem is that if this temperature, our mean temperature goes above this level, you see from here the temperature is decreasing, and only when it decreased to a certain level, these oscillations could take place. Because of certain feedbacks are very slow, these feedbacks could not take it to a glacial period and bring it back to interglacial period unless the mean temperature is below a certain level. And that happened at that time when Earth cooled to that level. And now if by some activity of the humans, we take it to a level that 2 degrees that people talk about. Why 2 degrees we have to maintain? If 2 degrees above the pre-industrial level it goes, it will come to this level. And in that level, then what will happen is certain other feedbacks will accelerate the greenhouse effect and take it to this period, like 55 million years ago when we had a very warm climate, like 10 degrees warmer than today. And what will happen is, you can imagine. So this is the problem we have to understand. And so this is the main problem. I have already talked about that, so I don't need to go those line by line. So this is the context that we need to. So associated with that, if we see where how the carbon dioxide changed during this period, the carbon dioxide actually changed very close to how the temperature changes. It's somehow the system has this. This is almost like what is they call Gaia hypothesis, or what people talk about. The environment and the climate maintain themselves, and where temperature what affects what is something that is interaction that we have to understand. So even when it is very warm, there was very large. There were like carbon dioxide is like 5,000 parts per million. But there is this glacial period. It was like 180. That this is that 300 million years ago. This was like 180 parts million. These are based on all kinds of paleoclimatic data proxies. There are some errors, but I think the overall the numbers are largely ballpark is correct. But there are error bars in all these. But I am not going into the error bars right now. So and then when we come here, of course this is the 65 million years ago, and then today we are here, which in the glacial period used to be again small. So let me just show you now, go up to the shorter period. Now the current crisis, if I now come to the current climate change, this is the essentially the increase in the global temperatures in the last 200 years. So in the 200 years, if we see, this is the pre-industrial level, and from pre-industrial level, it has reached to about 1.1 degrees today. But why it is important? It is important if we see, instead of 200 years, suppose I go to 2000 years, then what do we see? What we see is the temperature has been quite much lower, or almost like pre-industrial level, until very recently. And then in 100, 150 years, we have simply shot up. And this is the problem. So the rate of change in the last 100 years is tremendous. And there's nothing unprecedented in the sense that we don't have any history. Of course, in the very past, we cannot have enough high-resolution data to tell whether such thing happened or not. There is no evidence because there is no data. But in the recent, at least in the recent 1,000 years or 2,000 years, even 10,000 years, we have not seen this kind of way. That for that period, we can have better data, and we don't see anything like that. Okay. So this is important. Now, how is it in the context of the last 1 million years? So we have data from Antarctica today, where from the ice core we can extract what is the temperature variations, carbon dioxide variations, and methane variations, and so on. And this is a very fantastic information, climate information, very reliable, and we have. What it has revealed is that the temperature flux, this certain isotopic ratios are used to infer the temperature informations, and there are of course ice inside the ice. There are air bubbles. From the air bubbles, actually you can actually measure those carbon dioxide and methane concentration and so on. So this information is quite reliable. That we had this temperature. This is a proxy for temperature variations. We had this warm periods, cold periods, warm periods, cold period. These are interglacials, and this is the glacial period or the ice ages. Like that, we had about 8 or 10 cycles of that. We have good data now. So, and during that period, and we are here today. That is our interglacial period. Okay. So we had methane changes, which were like about 600 parts per billion, okay? And what was recent, I did not show the recent data. No, I'll come back to that. So remember that this, so it was like, it was between 500 or 400 and 600 parts per billion is what changes during this whole glacial, interglacial cycles. And how much is carbon dioxide changing? They are changing from 180 parts per million to about 280 parts per million. That's all it happened during those whole interglacial changes. And today, where do we have? We are here at about 420 parts per million carbon dioxide, from 180 parts. All the, as far as we know, all the interglacials in the past had about 280 parts per million carbon dioxide. But today we have 420, and methane we have about 2,000 parts per billion compared to about 600 maximum that they used to have in those interglacial period. So this is a problem. And that is a major problem we have to reconcile. So how this is related to the human activities? So if you plot the human activity or the population growth and carbon dioxide and our gross domestic product, this is the index of development, right? So everything was way below in the last 2,000 years, okay? So somebody has put together this data, okay? There may be some small errors, but this part is what is killing us. Over the last 150 years, the population has exploded, and so does the carbon dioxide. It's more or less goes to the population, and this has happened in the recent history. This is very much proportional to the human growth. And so is the fossil fuel emissions as well as the GDP growth. GDP growth and fossil fuel emissions are very closely linked, and the human population growth is also so much linked. And obviously, fossil fuel and carbon dioxide is closely linked. So these things are interconnected, and this is a cause of concern because we have to counter that if we want to live. So in the history, of course, there is close relationship between population growth and carbon dioxide. But how is it important? It's the problem is that we are facing that we have gone beyond the carrying capacity of the environment today. The earth has a carrying capacity. Apparently, one estimate is that 10,000 years ago, when population was small and all this degradation was poor, then probably it was sustainable when about 200 million metric tons is what the earth can apparently sustain population. So the vertebrates population must be equivalent to that. Otherwise, you won't be able to sustain. But today, we have gone over that 100 times or so. So as a result, what has happened is that the imbalance in the nature has taken place. When there was 1% of the wild animals constitute the total vertebrate and 99% were human, 10,000 years ago, today 99% is human plus domestic animals, and only 1% is the wild animals. So this is the reason. I mean, domestic animals are something that for our own purpose we have grown, and they have taken away the resources that is required, and therefore we are exploiting the environment to maintain those domestic animals. So therefore, this is the problem. Now, if that happens, the modeling, the ecologists and population dynamics people tell us that if you continue to exploit the environment beyond its carrying capacity, up till some point you will be allowed. But beyond that, the system will collapse, and then either there will not be enough to eat, or famines and other things will kill people, and so it has to collapse. And then it will collapse back, and it will be difficult to bring it back. And so that is what is another sort of scenario that we should be prepared for. And this has happened in the context of present crisis is that there were big changes in the past. There were mass extinction in the past. In the historical past, there are 5 mass extinctions in the past. But all these were natural, either due to a big meteorite or something that happened in the environment that produced an event which changed the climate in a big way. And that, but the recent or the current mass extinction, there is evidence that the rate of species extension in the last 100-200 years has risen above the background level by about 100 times, which indicates that now we are sort of heading towards another mass extinction. And this is more worrisome because now it is made by, is accelerated by the human activity. In all the past events, it was not. And therefore, this is a major cause of concern because the humans are very selfish. and you don't want to see reason for some doing things. And that is what is going to possibly have a serious impact on this. So, now let me talk a little bit about, before going to the sort of policy issues or whatever we need to do, talk about a little bit about how it has affected the monsoon. Now, what is monsoon? The monsoon, if you, I think there is animation here which is probably not working. Okay. So what is monsoon is essentially, unfortunately, there is an animation which while transferring to this another computer, it probably. So this is, what is monsoon is essentially is the movement of this, it's a rain band. This rain band we call is intertropical convergence zone. So there is a zone of rain band. It starts, normally it resides in the ocean to the south of equator in the winter, then it starts moving to the north around April, May, and May, June, and then in July it comes over here in this region, and then the monsoon is set up there, and then and again September, October it migrates backward, and this northward propagation of this seasonal migration of this rain band essentially produces summer monsoon over India. And associated with this, winds are very much coupled to this. The winds try to converge towards this rain band. Rain band essentially represents a large heating in the atmosphere. It produces latent heat release. That latent heat release attracts the winds. So the winds and the rain are very much coupled. So that is why we call monsoon a convectively coupled system. So the rains and winds are very much interchanged. So once the rain sets up in this, the winds then change from south to north. In the winter, the winds are also from north to south and going towards. So that is a change of winds are associated with change of. So this the monsoon winds, the monsoon is part of this annual variation or the rainfall in this region. And the summer it becomes like that, and the winter, as you saw, the winds are, the rain is here. Summer still there is some rain here in the equatorial region, but the major rain band is here. Now, so monsoon is associated with a wet summer and a dry winter, and associated wind reversal. In the winter, summer the winds are this way, the winter the winds are in the opposite direction. So the wind reversal associated with the reversal of the precipitation is the basic monsoon, which is driven by this northward migration of the rain band. And this monsoon is very deep in the vertical, in the sense that there is a big cell which produces this motion going up in the north in the summer and sinking here, and this produces this rain here in this region. So this is basically a very simple picture of the monsoon, and this monsoon has variations from year to year. And this is what caused our floods and droughts and things like that. So this is a time series of monsoon rainfall, which is deviations from which is a sort of long-term mean. And then sometimes it goes above normal by so much, then it becomes a flood. Sometimes it goes below normal by so much, then it becomes a drought, big drought. So, and these things keep happening. So we need to. That is a different subject altogether, what drives these and so on, and that was part of our bread and butter, try to understand how this happens. But today, I'm not going to talk about that much. What I'm going to talk about is just quickly tell you what this can which can happen to the monsoon under this, the climate change. The climate change means the global temperature has increased or increasing, and under that condition, how it will affect the monsoon, in what way it can affect. It can affect in three different ways. One is that it can increase the frequency and intensity of the very heavy rainfall years. That's what I had shown you in the beginning. You see, that's exactly what it can do, because now more moisture is there in the atmosphere. The more moisture makes the atmosphere a little bit more unstable. More unstable means a little push can produce a big rain event. And so, and there is more moisture. If it pushes, then it will bring in more moisture, converge it, and produce a very big event. So that's exactly what happens. And this is there, evidence of that is there from observation. And So the other thing that can happen is that, okay, there is a lot of more moisture in the atmosphere. If there is more moisture, can the total rainfall in the season increase? Because there is more moisture, maybe you can precipitate it, but moisture does not convert itself to rain, because for rain, you have to lift them. So to increase rain, to increase mean rainfall over the whole country, some large scale uplift is required. So that doesn't happen all the time. So therefore it can happen, it may or may not happen. Everywhere it doesn't happen that rainfall will increase. But in monsoon, therefore, there is no big increase. But there is a slight increase if you take over a whole period of 200 years. There is a very small increase, about 3% has seemed to have increased. Over 3% per degree increase in the global mean temperature is happening today. But it's a small increase. That is because this rainfall, actually on a large scale, is governed by also the large scale atmospheric circulation. In some places there is maybe subsidence, big subsidence, the air is sinking like desert. Then even if you somehow try to increase the moisture, it will not produce rain, right? So it has to, some large scale uplift has to help it. If that helps, then it can increase. So in monsoon is actually happening. I'll show you that it is increasing in some place, decreasing in some other place. And then what happens is, then there is also possibility, this is the third, last point. The second point is that, okay, this distribution can also change. So one of the important feature of monsoon is that there is more rain to the east and there is less rain to the west because they are desert region, of course, except for Western Ghat. Okay, so this is an important feature of monsoon. Bay of Bengal and in northeast gets a lot of rain, but Gujarat, Rajasthan gets very little rain, and these can also change due to climate change, and we have recently shown that that is changing. I'll give you so one question that we have been asking is that, okay, could actually change the spatial distribution of monsoon by climate change? In the past, many thousand years ago, like Vedic period or Harappan civilization period, this region was very wet. There was a lot of civilization, and there is evidence that there are greeneries. And paleoclimatic studies have, and archaeological studies have established that there was more precipitation and vegetation in this region. Of course, Saraswati was more active in those days and so on. So could that happen in future? So we looked at that from the climate change point of view and find recently that, in fact, there is actually a shift of monsoon towards west. In other words, the rainfall is changing, is in this eastern side. It is actually increasing at a much slower rate. On the other hand, it is increasing at a much faster rate in this western side. So there is a possibility now that in the coming 100 years or so, this place can become much wetter and greener. And that is a very important, I think, important possibility. Again, I'm not going to go get details of this. This is an evolving area of research, and I think this is an interesting signal that that is now currently being investigated. The possibility of this being, for example, think about if Gujarat, now the mean rainfall is about 40 centimeter. If a 50% increase take place, it will become 60 centimeters annually, right? That will make a big difference. Where there is and that is a possibility. So okay, let me just make one comment and then leave this. So one of the important thing is that this about the extreme events that I mentioned. These extreme events are going to increase rapidly, and there are some places which are actually being affected already very badly. For example, northeast. Northeast, you have mean rainfall is very high. mean rainfall is about 250 to 300 centimeter. Okay, in central India, our mean rainfall is 100 centimeter. Okay, less, even less than 100 centimeter, 90 centimeter. Now, the extreme events there are like 15 centimeter a day is very extreme. In Northeast, the extreme events are the 90%, 95%, 99.5 percentile is more than 45 centimeter. Or 40 centimeter. Okay, so now these numbers have doubled or are going to triple in 50 years. And those numbers are like, so those 50 centimeters are like, 50 centimeter a day events are like cloudbursts on a large scale. Imagine, cloudbursts on a very large scale is happening. And those happening numbers are doubling. And think how much that will happen, that will affect the local hydrological disasters. And that is something we need to prepare. But I don't think anybody is thinking about that. And this is what I am thinking is something, the adaptation strategy we need to build to adaptation of these. We are not doing anything for the mitigation, but I think at least we must do adaptation. How to prevent damage and destruction due to this, and how to help people to cope with this. Because every year, this is, last year floods, only one big flood came and 400 people were died. And lakhs were sleeping in the road for more than 1 month. And nobody but people forgot. And I tell you, this is going to increase manifold in coming 10 years. And unless we do something, the people will not tolerate this, I think, anymore. So I think this is something that is we need to, okay. So my message is that I think one important thing is that the climate mitigation, we are talking about climate mitigation or doing nothing about it. And nobody has been doing anything about it. So at least let us do for adaptation something. Adaptation also, what are we doing? We are not doing any policy initiative on adaptation, country-wise or regionally. I don't see anything. So I think this is where we need to focus on. Because next 100 years, because already the carbon dioxide and the greenhouse gases in the atmosphere is going to drive the temperatures. Even if whatever we do today, at the end of the century, mean temperature is going to increase to 2.4 to 2.7 degrees, at least 2.7 degrees. That is already over the critical values. Even if we do everything that is proposed today, which we are not doing. So, therefore, global warming is going to continue, at least for this 100 years, 2 years, definitely. That is, my grandchildren also will have to face that. Okay? So then, so at least the adaptation is something, is an immediate necessity. We need to develop a strategy for that. So now let me talk about the sort of how industrial revolution has. It is well already I have said, but I think I can finish this quickly. So as I said that the industrial development is definitely is a major factor globally, not necessarily in India. And that is because that is related to the energy demand. Today, you see, the energy demand is increasing exponentially, and nobody is doing anything about it. And we are talking about development in the next 10 years also at the same rate. That means you are demanding the same energy and requirement. So in my opinion is that unless we stop the energy demand, I think it is impossible to talk about sustainable development. And this energy demand is going on exponentially in the last 50 years. It is actually has really, and out of this today, only 17% is renewable, and more than 80% is still fossil fuel. And we are talking about the next 30 years, we will reduce it up to 80% renewable. But that is just not enough. So why this is happened. It's a nice picture. Actually scientific reporter who actually created this very nice picture where how people have contributed to this, different countries. And this is used for political purposes, but I think we need to understand this. It has a lesson also. See that this is China's contribution. So in 1900, we had only 2 gigatons of carbon dioxide in the atmosphere, okay? And today, we have 37 gigatons of carbon dioxide in the atmosphere. Okay, this is the atmospheric carbon dioxide, not the emissions. Emissions are much more, almost more than 50% is absorbed in the ecosystem. About 50% or less goes and remains in the atmosphere, and this is our carbon budget, roughly. So see how it is exploding, but it is exploding from 50s. Okay, remember this. This is interesting. Now, if you go to USA, they started in 18th century, 19th centuries, and in the 20th century, they were already contributing too much and still increasing that contribution, okay, percentage contribution. Okay, then European Union. Both these two are major contributors. They also did the same thing. It started in the 19th century and then contribute, and then all the others, like India. India is still, this is our argument, that we have not contributed so much, but today, of course, we are the third emitters in the whole globe. And you see, we also started around 50s, 1950. Still, it was very little. Only in the last 30 years, we have 20 years, not even last 30 years. 20 years is what we have just trying to explode and become third in the world. So we have to be concerned. I'm not making any political statement here. But the rest of them are also not important. So this brought out the whole philosophy of what is common but differentiate responsibility. And this has been a philosophy of how international community must engage in to reduce the emissions. But this, unfortunately, everybody agrees to it. Nobody does much to, when they actually have to come to action, they don't take action. So this is my problem. So why I'm saying that this is not sustainable, as I said, is that modeling studies have shown us that, okay, if I do so much, then with everything that is happening today, our best estimate of temperature at the end of the century is going to be about 2.6, between 2.6 and 2.9 degrees. But 2.7, 2.8 is kind of average we must expect. So, but we had promised all kinds of action which can reduce it. But from promise and this is the kind of, this much difference is there in terms of how much we need to do and what is required and what is done today. What is done today, there is a big gap between what we need to do and what is done. And this big gap, and we are not seeing how this gap is going to be filled in the next decade or so. There is no plan anywhere how this gap, unless this gap is filled, even this may not be sustainable. So, and that is my problem. Now, what happens then, if that happens, in the best case scenario, let us say that this is the 2.6, SSP2, that is kind of middle pathway. If that happens, even then, the world will look like this in temperature. It will warm up so much in this. So the feedback in the polar regions, already the sea ice is melting and the ice will melt more, and so that will accelerate much more by the end of the century. And then, of course, these hot temperatures will, the permafrost will melt. The more methane will come, more burning will take place, because permafrost, the dead vegetation will burn, and then more methane will come. So this greenhouse gas effect will further accelerate. And so that is where it will be impossible to stop if we go beyond that. And that is, so I'm being a climate activist today. Now I'm talking about the extremes, but I think we need to be worried about it. It is something that I think we cannot. So what needs to be done? So again, the IPCC, very recent last year, IPCC report came out, and they actually made a good study and mentioned about the, and it's very clearly one that the window of opportunity is running out. We have to take action today. And why we need to take action today and why the action may not be sufficient is because what needs to be done is we need to have inclusive governance. We need to have finance for innovation. The finance is not coming out. Ecosystem, we have to consider the ecosystem stewardship. Development must consider the ecosystem. Today, I think we are not thinking, we are doing a lot of development which is just not, because we argue that development must be there. Whether the ecosystem dies or not, it is not a concern. That cannot continue. So that is, and synergy being, these two things are related, synergy between climate and development actions, behavioral changes. I think this is another thing. The lifestyle has to change. Without lifestyle change, we cannot bring this, make this happen. And that lifestyle change has to be those like common but differentiated lifestyle change. We have to make that, and that, who will make that? And that is our biggest challenge. So this, why this is not, may or may not work is because currently the poverty and inequality and injustice is so prevalent that unless this goes away, this is very unlikely to happen. And that is like economic developments are sort of, response is all siloed, lack of finance is not there. And this development goals that we had put forward, they have been just running out in terms of trade-offs, this and that, and not really we are following the development goals. And so it is very unlikely that this is going to happen. India is still thinking about the development, and in the future, in the growth, we are thinking about 8% growth over the next 3 decades. This, I was part of this development vision from some document is being written, but our vision is to still grow, and that is I think, in my opinion, is not quite sustainable. India has something interesting going on. We have discovered the lithium source, the big lithium source from Jammu and Kashmir, and that will give a boost in our energy storage and also the electric vehicles, which is, I think, very good thing. But keeping that in mind, how we can go on a more sustainable path is something that we need to think about. So why I am saying is that this is not great. I think it is moral and ethical in our part. We require that after creating the crisis, it is we are morally and ethically responsible that that we have to take action today, and the action so that at least we can reduce the warming below 2 degrees beyond this by the end of the century, which is not going to happen, I think, today unless we do something very, very drastic. And because we also, I say that the cost of the climate crisis is not factored in many of this development, because we are thinking that everything will go as usual. I think what I am saying is that all these disasters are going to actually affect the economy so much that this 8% growth is going to be completely impossible, no matter what you do. That is what I am going to say. The threats of development is essentially associated with inequality and the conflicts. Inequality is growing today. today the only 5% of the world population controls 90% of the wealth, and that is probably is going to really create social unrest, and conflicts between countries are increasing, and Ukraine and Russia war is just one example, and so therefore these are kind of holes that are there, and I think you just need one small hole just sink the ship. But most importantly, I believe that is not sustainable because there is this trust deficit between different countries, and especially the countries, the rich countries, and their actions. So finally, we need to do a different model. And that model is, sometimes people are now, the ecological economists are saying that we don't need to go at this GDP, use GDP as the growth model. You can still have growth. I mean, so you have to have something called a post-growth model. The post-growth model can have, GDP can remain at that sort of not grow, but still have development which is more socially equitable and still can sustain and sustainable. And I think there is a lot of work done, a lot of papers. So I have read several papers on this interesting topic, and let me go. So these are a couple of papers that I mentioned here. So these kind of people are talking about it. It's an interesting model, and I think we need to think about it. The rich countries need not take GDP growth as, rich countries as well as developing countries like India and China need not have that as a model, but we can change the model in such a way that we can still have equitable growth. But that needs certain amount of changes in our or certain sacrifices we have to make. And that, I think still, this model is something interesting, but how it will affect the climate has not been modeled so far very well. So this is, we are arguing that now, that the climate modelers like IPCC should consider this degrowth model or the post-growth model also as a part of their SSP scenarios, and then see how it will help the environment, how it will help to control the climate. So if we can show that also better, that will also help the policymakers to also probably take stock of this. What I am saying is that we need to take this forward, and this argument should be discussed. And the climate IPCC should consider this as a modeling scenarios and built into our future development model. So going forward, we need a socially equitable model of development which is sustainable, and degrowth and post-growth model may be one of them. And so this is what I think I still get always. Remember this saying from Mahatma Gandhi, saying the earth has enough resources for everyone's need, but it doesn't have enough for everyone's greed. And since the greed of the human being, he has created us, landed us this problem. And therefore, this is, so we have to keep this as a guiding light for our future development. So that is what I'm saying here again. So IPCC again has been doing a great job in bringing out what is needed to solve some of these international problems, the climate problem. And they have been one organization where actually we come into consensus of doing something. But when it goes to implementation, there is another issue. That implementation, the countries don't go back and implement them. That is done, that should be done by some international organization, another wing of UN. But UN has been so dysfunctional in the recent past that they cannot make them implement anything. So therefore, what we need is a new global order. I don't know whether it will happen. It may not happen, and that is this scary part of it. So with that, I'll stop, and thank you.
The question I wanted to ask is, forget about what North America and Europe and China and Japan and Australia need to do. But we in South Asia, let's restrict ourselves to India. If we talk about one or two things in particular that you feel are most important for either mitigating or adapting to climate change, what would those be?
Yeah, mitigating we need to, my personal opinion is that India is still arguing that we, okay, so we need to do more on mitigation. Okay, our philosophy has been that we have not contributed as much, and therefore we need the development. Our population is big. We need to increase the economy, or sort of strengthen the economy, so that the benefits will percolate to the population. But that's not happening, first of all. Secondly, that is why I think that India also cannot continue this model of development, and we need to do more on mitigation, and we cannot go on giving the same argument that we have. Of course, it will have it will require certain sacrifices, and we will be as people we are willing to make that sacrifice. Is the government willing to make that sacrifice and go to the people and say that we're going to do it? This is not what is happening. So I think definitely our goal today going to zero emission is 2070. I feel that is just not sustainable. Whether it is where we have not produced enough emission so far or not, it is simply not sustainable. As a human sort of response, we need to do more, and that is what I am. So emission must be reduced. This model is not sustainable, and it is not good for the country also. Eventually, the people are also going to suffer for this. Even our country people are going to suffer. So therefore, I think I feel that is one thing that we need to do more on emission. But what we are doing today is trying to build more on renewable energy, which India is doing a reasonably good job, but not too late, too little, too late. And I don't see the investment that is required to make even this going from 20% to 40% to 80% by 2050 is not possible unless we make enough investment. It's not going to happen, and that much investment is not coming. I don't see where it is coming. Government is not putting money. They are expecting other private people to come. Forget about it. I don't think that is going to happen. So unless we put more investment on, we need to do two things. One is cut down emissions, first one thing, and or put more money on innovations for renewable energy and renewable sources, even more than today we have. And so I think we need to do much more than what we do.
If I can ask a follow-up question. One of the tables that you put up showed both the quantity as well as the proportion of invertebrates as part of the problem. I'm not a vegetarian. I wonder if most of us become vegetarians, whether that would at least mitigate part of the problem. Because whether it's methane emissions or many of the other things that go into growing domestic animals suitable for us, whether it's for milk or whether it is for meat or anything else, that seems to be a big part of the problem.
Yeah, I think that's a good question. I personally feel that see, if you look at the domestic animal, it's a very big part of the whole vertebrate population, right? So that is a big contribution. So therefore, if you completely cut down the domestic animal part, and if you in our food resources, starting with milk, I think it is impossible to do that today. With the population that we have, to feed the population is simply not possible, because I think that is where the problem is. If you cut down today, a large population will simply perish in a short time. So that is so I think, but reduction in that will help. Will definitely help. But I think that is more of a, it has to be, it is the part of our de-emission scenario. This may be one component that we reduce our domestic animal growth and complement it with something else in terms of energy for the people. After all, that energy goes to sustaining the human, right? Basically, that is simply that energy is, we are consuming that energy and for our own sustenance. The growth of this population at that level, you need that much energy, and we are growing there and bringing it to you to sustain. So that is what is going to create the problem. So you can have a part of that as a solution, but I don't think that should not distract us from the emission problem. So we can use that sometimes to use as a distraction to the emission problem. That should not happen. Emission is the fundamental cause, and therefore we should control that.
Thank you. Hello, Dr. Goswamy, excellent talk. I think we need such more talks that are really data-driven, And my name is Ankur, and I'm from Azim Premji University. I am another Dr. Goswamy's colleague. So, usually by nature I'm a very optimistic person. But after having read so much about emission cuts and also from your talk, somewhere I'm really pessimist, and I think, we are really, really going to fall short about emission cuts. That is what even I believe, that it's probably just not enough. So instead of mitigation strategies, I think we should switch over to more resilience. How do we develop or cope up to what is going to come? As you said, building, preparing ourselves for monsoons, more rainfall. So something that much more concerns me is how do we talk a lot about climate resilience agriculture. How do we grow our cropping system? And recently we have lost a lot of crop in the last few years due to either excessive heat or excessive monsoons. So do you think, what should be, in your opinion, what should be a proper or maybe a part of a resilience strategy as far as agriculture is concerned? How do we modify our current agricultural practices, which are already very monsoon dependent? And also, our cropping pattern, when do we sow the crops and things like that? What, in your opinion, could be, we could do something about it? Thank you.
Okay, thank you. So I'm not an agriculturist, but what I understand is that obviously this increase in the floods and flash floods and the large-scale floods are going to really affect the agricultural growth, and so. There is effort going on in the country to develop the flood-resistant paddies and especially paddies because in Assam and all that, the paddies need a lot of water, but then when there is flood, it submerges. When it submerges, it really kills it, and it stays there for a long time. It completely submerged, it doesn't need completely submerged. So that people have started developing it, but I think, and of course, with this climate change, we are also going to increase diseases. So disease resistant and water resistant, sort of submerging water resistant crops are being developed. But my feeling is that that's not going to be sufficient in the coming, several decades coming forward. Because of two things. Because this thing also is going to be a problem. The productivity is going to go down because of these, no matter what. And so, but the population is increasing, and the food production over the last several decades have now plateaued. The first green revolution has now plateaued. It is not increasing our food productivity at a rate which is required to sustain the future population. Now, to do that, we need one more thing. I think we need another great revolution. Increase in the productivity per hectare, but without involving fertilizers. So that is going to be, I think, the next mission that we need. But how to do that is a challenge. I don't know, you might have to go to genetic engineering or whatever, but whether that will be sustainable or not, it is a question. So I think that is going to be a problem in the in the future, because the per hectare increase in the places where there is not much use of, like in in Assam, we use little fertilizer. Now people have started using it, but our per hectare yield is much low compared to Punjab, where you have used fertilizer and then productivity has gone up, but that also is saturating now. So, and fertilizer using further is not a solution. Again, it is not environmentally sustainable, because it is causing more diseases to people, and therefore we have to have productivity increase without fertilizer. So how do we do that? This is innovation we need. So we have to think about that, how to do that. So this is where I think the new innovations are required. Investment is required. A lot of research will be required. Investment will be required. So this is where I think that is the direction the agricultural innovations need today.
I actually maybe have a follow-up question to that, what Ankur was asking. So when we see all these drastic changes of rainfall, right, on the western states, it's a huge change of what we're actually expecting to see. How is it going to actually, how do you see the adaptation towards that, in terms of crop patterns, maybe rotation? That seems like a really, really big thing that we have to actually work on.
Absolutely. I think that is a very important, a good question and important question, because what happens in the West, normally the rainfall, mean rainfall itself is small, 40 centimeter as I said. The 40 centimeter rainfall comes from large number of big events. In the northeast or central India, the 85% of the mean rain comes from small events, but only 10% of the rain comes from big events. But in western India, where there is a kind of semi-arid region, mean rain comes from bursts, a few events, big events. And those, so about 50% of the rain comes from just a few events, or even more, 60%. So what happens is that those big events are going to increase, and so if big events increase, the big events produces floods and erosion and runoff, and therefore that is going to be a bigger problem and those semi-arid regions are more prone for erosion, because their soil is sandy, and so therefore more erosion will take place, more runoff will take place. The water will not stay and help them. So what is required is they will have to do more of water management in a way to recharge groundwater. So to do that, some plans are already there, like recharging water bodies and so on, but we need to improve that in a very large scale. So artificial water bodies should be made smaller scale, not dams.
Innovation can come in there.
Innovation can come. Small water bodies must be produced in other regions, so that you capture some of the rain that come in bursts and let them percolate and build up the water level, so that in the winter season that water level can be used to sustain agriculture, sustain some growth. Otherwise vegetation will die out. Why the vegetation is poor? Because the winter is long and dry and it cannot sustain vegetation, right? So we have to sustain vegetation. Once you can sustain vegetation, then, and to do that you need groundwater. So groundwater has to be increased. So groundwater can be increased only if you have this water harvesting in a very innovative way and on a large scale. Some work is already on. It need to enhance that in a very in a big way. And if we do that, and groundwater is good, then winter can be you can sustain by pumping groundwater, and then vegetation will grow faster. And then once the vegetation faster, the climate will also stabilize. So I think this is an important feedback that we need.
Thank you, sir. There are quite a few questions. So introduce yourself, make the questions short. So.
Yeah.
Yeah.
Yeah. Hi, I'm Biplab. I'm a journalist at Reuters News. So my question is specifically about like alternate sources of energy, right? Like we're talking about renewable energy, and especially like geopolitical events over the past year has sort of illustrated the persisting sort of dependence on fossil fuels, on crude oil, especially in the Western world. And I mean, the globally as well, like, it's sort of reiterated the continuing dependence, right? In that sort of, backdrop, like, where is the hope in sort of like, developing renewable energy, investment in renewable energy, and, is there, and especially like more specifically, I wanted to know from you about if there is, in terms of nuclear energy, right? We talk a lot about it. It's a talking point. There has been some breakthrough in the Western world about nuclear energy, and it's a buzzing sort of discussion in climate discussions, right? And I wanted to know, like, is there hope there? What is the pace at which it is being developed, and is it sufficient, the study at the pace at which it is happening, and how can it be a sort of feasible alternative? Yeah.
Mm-hmm. A very long but very interesting question. But I'm not an expert in energy, but I believe that what is being done is not sufficient and not enough. And not enough innovation is being is invested into that innovation. But I think only thing I can think about is nuclear, actually. Nuclear also in fusion, because the other nuclear is not very. But fusion, there is some hope. In the recent past, there is some, but fusion has been going on for last 50 years. We have not been able to really come up. But now there is a big project at ITER going on in the Europe, which is expected to break this and come closer to commercialization. But in USA, there is some recent study by energy department. They have another source of fusion which is coming out. So fusion seems to be a future. I think we need to invest much more on that so that we can convert that into. If fusion works on a large scale, then I think we can solve the energy problem to a great level. But other energy sources are still limited. Of course, solar is still there. Solar, we have to, as much as we can, we have to extract. The other sources are kind of, it cannot really make a big difference. So I think the breakthrough can come only through fusion, I think, fusion energy.
Thank you, sir. So can we have the second question, sir? Please keep the question short.
Sure. Hi. This is Jay. I'm associated with a non-profit called Initiative for Climate Action and a consulting firm called Zero to Positive. So thank you, Professor Goswamy. A lot of inspiring words and work that you've done so far. I think a question to both of you. One of the slides mentioned that civil society organizations, governments, and private sector need to collaborate. So in your experience, in both of your experiences, what has worked and what hasn't worked in making this accessible and actionable for these collaborations? So I think that would be very interesting to hear.
Very difficult question. Civil society is actually, the people in general are very concerned, and they are contributing their little bit. I'm not saying that people are not contributing. People are already contributing. But the contribution from the people are not going to solve the problem. The problem needs to be solved at a very larger scale, and that can come only from policy decisions, policy changes. And if that doesn't happen, the contributions, we can always do contributions by individuals, then you and me will do our bit, but it will not impact the problem. And that's what's happening, unfortunately. We will continue to do that. And that civil society is actually, I mean, most of the people I know are conscious about it, and they do whatever little they can do in terms of saving energy and green energy and so on. But what is needed is a big policy decision, and that is again is a large responsibility comes from the rich countries, and they may not do it, and that is our major concern. So, as far as private partnership is in India, as far as I see, the private institutions are doing whatever is required by law. But they are not coming forward as how much is required by sort of philanthropically, how much needs to be done. The philanthropic contribution from India in terms of renewable energy, I don't think, I don't know, it is zero or whatever. A little bit. Little bit. So I need, that is what is required. So we need, that is where the private organizations or the private players, if come out more research and development on this, and then it will make a difference. And which is I was mentioning somewhere that government also needs, private also needs. Government must also come forward and do this, and then private must reciprocate or do more. So this is what is not happening.
I would actually, to add to that, I would say, we need probably more engagement, we need more communication, we need more programs like this, even at a much, like a bigger scale. So that has to go very widespread. I think that's when we just initiate it. Thank you, though. Yeah.
Thank you so much.
Yeah. So we are, I hate to say, how much time we have, Sashat? So, yeah, so we'll quickly go through the questions because you're kind of running out of time, right? So yeah, keep your questions short.
No introduction?
Please, no, yeah, quick introduction.
I'm Kritik from the university. My question was in regard to, there was a lot of emphasis on social equity for future mitigation. So I just was curious to know why social equity is important in the case of climate change. That was...
Okay, good question actually. Why social equity is important for climate change? Social equity is important for sustainable development. I don't see climate change. Sustainable development means if social equity is not developed, you cannot continue development because the people, I'm not a sociologist also, but I can at least feel that if the equity becomes so large, inequality becomes so large, then social unrest will take place. You cannot, the civil society, people will revolt, and that the development will get affected. Okay, so there is a development cannot continue with inequality, and so that is a common sense problem. I think I'm not talking about from social science point perspective, but I think it is beginning to happen because as this inequity is increasing, look at China. For example, they grew at 10% for 20 years or something, or 15 years, and then now their economy is going down, and also social unrest is increasing. You can see it is growing up. I think one day it will explode. Similarly, things will happen elsewhere also. So inequality is not a sustainable solution for development. That is my common sense argument, not a social scientist argument.
Thank you, sir.
Thank you.
So can we have the next question? Please introduce quickly and quick question.
Yeah, hi, I'm Akhil. I'm from Azim Premji University. So this is just a question regarding when you talked about sacrifices that are to be made. So in your opinion, what are certain necessary sacrifices but yet feasible ones that could be made?
Okay, I feel, again personal opinion, okay. So I feel that the governments around the globe cannot continue the investment in the defense, so much investment in the defense. The defense spending is so much and defense industries are asking for so much energy, this cannot be sustained, and therefore that is one of the biggest. And today, what is happening? This inequality is only affect. The instability in the world is only gainer is the defense industry. So we have to cut down the defense spending. If the 5 of the world's biggest defense spender cut down 50% of their defense spending, that will spend. They will save so much money that can go into innovations of renewable energy, and that is what is not happening. So that is one thing that I personally feel needs to be done. Then of course the unavoidable expenditure, avoidable development, avoidable energy consumption should be avoided. Like suppose things like the rich people have 10 cars, even if they need only 2 cars, and they have very luxury cars, and they have a yacht and a airplane. I think these are not sustainable. Okay, so these are things that we need to sacrifice. And in India also, there are people who do that, right? So things like that are not sustainable. In the name of that they need investment from those people for growth, we cannot allow them to spend more energy. So we have to. This is the degrowth model where we have to make sacrifices where, and still then go into industries or something where your profit may be a little less, but still you have profit. But at the same time, you generate more jobs and sort of equitable development takes place. So these are kind of sacrifices that needed, but whether that will be possible to do or not, I don't know.
Yeah, that's good. Yeah, thank you, sir. Yeah, can we have the next question, please?
Hi, my name is Kirtana. I just finished my 12th. You mentioned that we are carbon emissions increase with increase in development, and in between you mentioned that we need to look at development that's more in synergy with our ecology and our environment. But the thing is, development is typically associated with an increase in carbon emissions. This is seen all across the world. It's also why you've got this entire concept of carbon budgets, and why as developing nations we are supposedly on the political scale entitled to a little more emissions today than already developed nations. But how can development be more ecologically sustainable or in synergy with ecology? What would that look like?
That's what I said. So already as I said, it is related to the population growth. So all these developments are to sustain the population, because to create the food and jobs for the population, and therefore we need development. Now, but the population growth has reached such a level, and that we cannot continue this kind of development that will produce the same jobs. And so I think we can still produce more jobs if we are satisfied with less growth, in the sense that less growth of our wealth. And suppose instead of very big industries, you go to smaller industry units where you create more jobs, but your profit may be less, but you have to put some investment. But investment return may be less. So we have to be satisfied with less return, so that you will use less energy. So that is the kind of development model that we have to. But with this population, we have to do something to feed them, right? But how do we do that? So we have crossed that problem. That has that sort of point where we cannot continue the type of development that we are doing. So we have to change that model itself. I am just talking about one way. We have to think in a different way also. If there is another model which will help us. So we are not thinking. I am opening up that discussion today, that we need to think about a model which will be sustainable. But what we are doing today is definitely not sustainable, and that is where I'm not saying that this is the only way that it can be done. But whatever we do, somebody has to make sacrifice. Without that, it is simply not. Because demand on energy must be reduced. And how do you achieve the goal without having the energy demand? And that is the innovation required. So you have to come up with those. Those are the also research that is required.
Okay, thank you.
Thank you. So yeah, can I have the next question?
Yeah, hi, I'm Abhinav, a final year economics student at Azim Premji University. So my question is, do you think that India's response to this climate crisis should also exhibit slight diversity across regions as well, because the impacts are going to be different across regions? And when you think about the costs to this, how do you think the costs should be shared equitably, given we have seen the cooperation failures in the cross-country climate negotiations? So how do you see that?
You want to answer that?
I mean, in economics.
Yeah, actually, India itself is a diverse country, and therefore there will be regional differences and all that. It's very hard to. So we have to come up with a more equitable distribution of that development within India. But that's a very separate question. We are not even thinking about that. But let us say within the world context, because the climate crisis is not India's problem alone, not created by India. It is created by the world community, and therefore it is a global problem. And therefore a solution has to come from global. But India must be a part of that global ecosystem of management of the climate, and that ecosystem we have to build by concerning. Coming back to the regional, it is hard at this point of view. Let us first think about the big problem, and then once we can come to a solution of the big problem, then within that solution, how we can make it a regional development, we have to think about it.
Yeah, I think in a global context, it is probably not much diversity in here. If you want to look at India, right? So we should probably worry about more about global diversity,
Correct,
right?
right
And
now.
then maybe at one point we'll get there, right?
We'll
You know,
get
if we grow like as a India, but as of now, we should probably think about the global diversity, right? So great question though, yeah, thank you. Okay, so this one, I know a lot of other people had questions, but I guess we'll take this as the last question. So go ahead.
Hi, I'm Gaurish. I wanted to ask about developmental goals and developmental models that we talked about, and clearly that organizations like UN, they're more westernized, but our societies are also like westernized. So I wanted to ask like what kind of developmental model we should follow because we rely on them. So I have this question about decolonization, and what do you think about it?
I mean, forget about decolonization, but I think the sustainable development does, we have to come back to nature, in my opinion. So sustainability is associated with living with nature. And because of the population growth, it has become impossible to live with nature the way 1,000 years ago you could do, right? So as a result, we have to find a better way of living with nature. But still we have to live with nature. So therefore we have to go back to the models that worked in the past and see how we can replicate it in the present context. So therefore, for example, there are so development should not be like blindly for creating wealth. That is why the post-growth model I am talking about. So instead of talking about development in the name of development alone, you have to think how it will affect the environment. Without affecting the environment, how we can make development. So therefore, for example, in the Northeast, we have these communities who used to live with nature only, right? In Naga and all that, they did not have much of development. But today, we are building roads and cutting out the hills, and that is going to change. And they had a system of how can live with the nature, because they will cut only a few trees, and the trees itself will regenerate certain and some part. There is a very interesting. I think some of you know. There's other trees. The other trees, and they cut down, and at some point of time, and then in other place they will grow it. And during this period, the barks of the tree will produce nutrition in the ground, and the other things they will grow. Potatoes they will grow, and things like that. And the other season, and the other places they will let it grow. It is a fast growing tree. They will grow after some time, then they will cut them, then grow something else. And then this wood they will use for something else, producing not only firewood, but also making matchboxes and other things and things like that. So there is a ecosystem which they were just managing within the environment, and then livelihood is maintained. So that is a kind of example of sustainable. How can we upscale this? Without and that kind of thing, there are examples. So take those examples and see how we can emulate them in a more sustainable way on a larger scale. And so if we can do that, maybe we can help. So I think there are some interesting models of living. We have to go back to our people, sort of environment.
Thank you.
Thank you very much. So I think I just wanted to summarize some of the session by saying a couple of things. First of all, thank you very much. You walked us through from the science all the way to the need for adaptation, mitigation, and how you're thinking, kind of suggesting a newer model, right? So that's great. It's a really nice walkthrough from the science all the way to when you're talking about resilience and adaptation. And so there is a good number of young people present in the crowd. So I just want to say you one thing, that it's a picture that we have seen. It's a grim picture painted, but that is the real picture. That's actually where we are walking into. But the generation which is actually going to be working on solving the problem, or when we help solve the problem, is a young generation. I'm glad to see a lot of you are here. So you should think about maybe a way to think about how we can think about innovation, different types of innovation, social innovation, technical innovation, any sort of innovation. To help this problem, to do that, first you have to understand the climate change. You have to understand, you have to be your it has to come to the mainstream of conversation, and then you have to start talking about it, right? Hopefully you know, this session helps you to start thinking about that. I know you're interested, that's why you're here. Be part of this series of Let's Talk Climate Change in the future as well, and let's talk about climate change a lot more. Try to understand it, like as an informed way. So thank you very much again. I'd like to thank you very much for your information.
Thank you very much for all. Thank you for all for. I must say that I am an eternal optimist. Although I have painted a kind of grim picture, but I am optimist. But I think you need to push people by making
absolutely, yeah,
making a grim picture. Thank you very much for listening.
Thank you.